If you subscribe to the channel, you'll get lots of interesting videos like this one. And if you like the video, it'll really help us out. Please comment down below for any other interesting things. That also really helps us out as well. Hi, welcome to another edition of BC Theory. So I'm going to give you some problems that I want you to work on related to proof by cases. So I'm going to do this one, but I'm going to give you another one for you to work on. So this one's saying if n is an integer, then this little formula right here, 2n squared plus n plus 1, is not a multiple of 3. So when you see multiple of 3 here, that gives you an indication of what n should be. So we actually are going to split this up into 3 different cases depending on what the remainder is when n is divided by 3. So here's how we're going to break it up. So case 1, n is a multiple of 3. So what is this? Well, then what we need to do is just figure out what this expression is when n is a multiple of 3. Well, if it is a multiple of 3, then that means that n is equal to 3 times k for some integer k. I don't know what it is. So let's just plug this in, plug this 3k into this guy up here. So 2n squared plus n plus 1 is equal to 2 times 3k whole thing squared plus 3k plus 1. So then what do we see here? Well, the 3 here is going to get squared, so that's going to give us 9 times 2 out front is going to give us 18 total. 18k squared plus we still have the 3k and the 1 out here. But what do we notice here? This part right here, I'm going to underline it. So this part right here is all a multiple of 3. But notice that right here, this plus 1 is not a multiple of 3. So we can actually factor the 3 out of the first part. So 6k squared plus k. And then whole thing plus 1. And that shows it's not a multiple of 3 because if it were, I can move this 1 into the inside of this, but I can't divide 1 by 3. And so that therefore this particular case shows that the statement is true. But we haven't considered all cases, we just considered one case. So let's do the other possible cases. So it turns out that I can't just have case 2 be where n is not a multiple of 3 because there are many, many other integers that it actually could be. So what I'm going to do, and there are actually multiple cases that live within that class. So what we try to do is we try to classify integers into equivalence classes, meaning that all of the numbers that are multiple of 3, I'm going to consider them the same. And I'm group them all into this case here. Then we need to look at all the other possible integers and group them into equivalence classes too. So it turns out the other equivalence classes here are based on the remainder when divided by 3. So so here's another case. N when divided by 3 gives a remainder of 1. Whereas before, because it was a multiple of 3, the remainder was 0, of course. So remainder of 1, that tells us that n is equal to 3 times k plus 1 this time, because the remainder is 1. Okay, so let's plug it in. So 2n squared plus n plus 1. Just plug it in. 2 times 3k plus 1 whole thing squared plus 3k. You don't have to put parentheses here, but I like to do it just so that I can keep everything straightforward. All right, so let's work on this one. So that's 2 times 9k squared plus 6k plus 1. And then we can simplify all of this out here. So that's going to be 3k plus 2. So then now we got to distribute the 2 across everything in here. So that's going to give us 18k squared plus 12k plus 2 plus 3k plus 2. Okay, so then let's group everything together. We only have one instance of k squared, so that's 18k squared. We have the 12 and the 3k, so I'm going to group them to be 15k. And then the 2 and the 2 are going to give us 4 total. Okay, so then we notice that this, again, is a multiple of 3 and 4 isn't, and so the same idea applies. Because this part's a multiple of 3 and this one isn't, and you add them together, it's not a multiple of 3 in total. Okay, and then finally, case numero tres, I'm just going to say the remainder is 2. If the remainder was 3, then it was already a multiple of 3 to start with, which was what the first case was. So really there are only 3 cases. Remainder 0, remainder 1, remainder 2. So let's just plug this in. So, oops, not k. So n is equal to 3k plus 2. Not orange, green. So then 2n squared plus n plus 1. That's going to be 2 times 3k plus 2 squared plus, again, parentheses, although not necessary. And then note here, this is a 1, not a 2, because the original equation had a plus 1 there, not a plus 2. So then let's expand this out. So 2 times 9k squared plus, well, 6 twice, 3 times 2, but in both directions twice. So that's going to be 12k. Plus 2 squared is going to be 4. And then let's simplify this bit over here. That's going to be 3k plus 3. So then let's simplify this further. We still got 18k squared plus 24k plus 8, because we distribute the 2 across, plus 3k plus 3. And we can actually stop here, because if we look at this as well as this, all of those together are a multiple of 3, but this 8 spoils the bunch, so to speak. And so it's not a multiple of 3. And so therefore, because we have shown it to be true in all possible cases, all 3 possible cases, therefore we have shown that this equation is not a multiple of 3 when n is an integer. So I want you to work on this one. So for all x being a real number, so not just integers, any real number, -5 is less than or equal to the absolute value of x plus 2 minus the absolute value of x minus 3 is at most 5. Okay, so what is this absolute value thing? So this is if x plus 2 is less than 0, then x plus 2 absolute value is equal to negative of x plus 2. Meaning that if, in English, what this means is that if this equation, x plus 2, happened to be negative, we just turn it to be positive. Okay, so if x was like negative 10, then negative 10 plus 2 is negative 8, then the absolute value sign would make this 8. And similarly with x minus 3. So this has to be true for all real numbers. So we can't actually group this into like remainder 0, remainder 1, remainder 2 or something, because there are many more real numbers than integers, and there's not really a case-by-case thing for that. However, there is a case-by-case thing with the absolute value sign. So the one case as a hint would be that x plus 2 is at least 0, and so that's the case 1. And the case 2 would be if x plus 2 is less than 0. And you may need to do some cases about x minus 3, but I'm interested to see what all of your techniques are. So hopefully that was interesting. Leave your ideas about how to solve this problem down into the comments, or any other proof by cases examples that you think are interesting. As always, please like and subscribe to the channel. It really helps us out. And as always, I'll see you next time.